All right, let's get started. Of course, I didn't fill in my announcement slides, so I don't have my main speaker in my announcement slide. Sorry about that. So you're John Doe from ABC Engineering.
I like it.
Like it? Yeah, something I didn't get a chance to. Sorry. So welcome again to week 5. I think by now we're sort of in the swing of things and whatnot. So I don't really have very many announcements for you because we're just going to continue along with the same pattern that we have been. So as you're aware, once our class is done today, I'm going to go on to Blackboard. I'll assign a quiz and whatnot based on the presentations today, and you all will have until next Friday at 11 a.m. to complete it. So with that, I really don't have any other announcements. Are there any questions or anything about how the class is operating? Yes, sir. Yeah, okay, so his question was about the card scanners in the back. I still haven't heard back from the university in terms of getting access, and I'm getting the feeling it's going to be a little bit more of a thing, a little bit more of a process. So our lab tech is going to come in a little later with the attendance sheets, and so I'm just going to have you all sign those at the end like we have been. So now, if you if you have your student ID, still go ahead and scan them. Keep in mind the university's collecting that data for like enrollment purposes and whatnot. So if you want, please go ahead and continue to do that. But yeah, any other questions? All right. So again, like I said, our lab tech will be in a little later with the attendance sheets. All right. So with that, we're going to keep on with the same pattern we have been. So we're going to start off with a faculty introduction. I have another civil engineering faculty for you this week. I have with us Dr. James Bryce. He's a new faculty here, just started here this semester, and he's going to tell you a little bit about transportation engineering. So with that, turn it over to Dr. Bryce.
Thank you, Dr. Michelson. Thank you. All right, so as he said, I'm Dr. James Bryce, brand new faculty here. I moved to West Virginia. I'm sorry, as my students remind me, West by God, Virginia, about 3 months ago, and I'm getting used to it. You all have, well, if you're from West Virginia, good on you. If you're not, well, we'll forgive you. You all have an interesting culture around here. You have these things called pepperoni rolls that are apparently your state food. And so, but they're chock full of pepperoni, which my dog loves because it's way too much pepperoni for me to eat. So I'm getting used to the culture around here. But as he said, I'm an assistant professor in civil engineering with a focus on transportation engineering. And really, if I had to boil down what I do and what my interests are and the types of courses that I teach into a single sentence, it's about engineering roads for the future. So I'm going to get into that here for just a very brief minute. First, I'll give you a little bit of background about myself. So I did my undergrad at the University of Missouri, go Tigers. I graduated there in 2008, so I'm still in the generation that absolutely despises the University of Kansas with all my heart. And it's really hard because apparently here on Marshall campus there's a lot of Jayhawks, KU graduates. Really tough to go through. Luckily, I got out of Dodge and hopped over to Virginia Tech to do a master's and PhD. They've got the Transportation Institute down there, which is world-renowned. Then I decided, hey, let's go see what the Brits do. So I studied roadways at the University of Nottingham in England, where, yes, they do officially have Robin Hoods on staff for the city and the county of Nottinghamshire. Went over and did 3.5 years as a consultant in transportation research, and now I'm a proud member of the Thundering Herd, which nobody can still yet tell me. When I was at Mizzou, we were Tigers. When I was at Virginia Tech, we were Hokies. But nobody can yet tell me what we are here. So if any of you can tell me, I would be very grateful, because we're not herds. We're not buffaloes. I don't know. Bisons. Are we all bisons here? There's no S on the end of it, though. Okay. Thank you. I also forgot to mention on there that there was this short time period that I fell and hit my head for like 1.5 years, and I was a structural design engineer. I don't know what happened there, but this is actually one of the buildings, after it was built, that I worked on, where I did structural design drawings and all of that. Then I saw the light and went on to graduate school at Virginia Tech. So what do I do, and what is transportation engineering all about? And fundamentally, what I teach and what I research here is how should we design our transportation networks. What does that mean? Well, what about connected and autonomous vehicles? We're all excited about those. I was just speaking to an Ohio State student on the way over here, and they've got this cool thing where they're deploying autonomous shuttles around campus there, right? Driverless shuttles that carry you. And we're all excited about that, but what does that mean for engineers? Because that's going to completely change our design system. Do we need stoplights anymore? Right? The reason that we have stoplights is so everything's controlled, but if your vehicles start talking to each other, do we really need those anymore? That's a question to answer. Who makes decisions in driving? Is it you or your car that gets to decide? If you're driving on a beautiful roadway and you got the ocean on one side of you, a cliff on the other side of you, and your car's doing the driving, and all of a sudden there's a child in the road, and you've either got to swerve off the road or hit the child, who makes that decision? Well, we still don't have that figured out yet. How do we mitigate the effects of our transportation systems on the environment and society? We build roads and we split communities apart. We need those roads for the economy, but those communities sure aren't too happy. How do we know what roads need to be fixed? Not only this year, but 20 years in the future. Because I don't know if you've seen how tax dollars get used and how they're worked. They want projections that far out. How do we know what happens? How do we know to do that? Well, again, those are the questions that I answer. And then, of course, can we use all these new tools that we have in terms of open source data, machine learning, artificial intelligence? Those are all fun buzzwords, but those are all parts that, aspects that touch my research. And so, again, being a devoted Mizzou grad and absolutely hating Kansas, I'll leave you on this. I love roads, and I love designing roads because it's one of the few pieces of infrastructure that we design to fail. Right? How many have ever seen a road that they built 50 years ago be in perfectly good condition, exact same condition as when they built it? That's never going to happen. We get waste materials. We get byproducts that chemical engineers give us and say we can't use this or we don't want to use this anymore, and that's asphalt. Then we go blow up some rock and we get aggregates, and then we go and we lay tons and tons of that down all across the U.S. in an uncontrolled environment, right? I've got friends that work down at NASA, absolutely brilliant, and they say we can predict what the air velocity around our muzzle is within this accuracy. And I say, that's fantastic. You guys are in a controlled environment. You tell me to go lay a bunch of asphalt down across the U.S. and try to tell you how it's going to behave. Good luck on that. Right? It's one of the few pieces of civil infrastructure that we do with that. It makes it complicated. It makes it hard. It makes it a heck of a lot funner than structural engineering. And it is it's what we do here. So with that being said, I tried not going over my time. Does anybody have any questions for me before I hand it back over? And you have actually interesting people coming to talk to you.
Any questions for Dr. Bryce?
Well, wow, there we go. I answered everything.
Thank you.
I've got a 12:30 meeting, so I got to head out.
You go right ahead. Thank you again. All right. So I'm just going to go ahead and turn it over to our main speaker. Our main speaker is from Braskem Americas. His name is Michael Higgins. He's going to tell you a little bit about their procedures and processes and maybe give you some advice as you go down this engineering road of yours. So let's hear from Mr. Higgins.
Thank you.
It's all yours.
Thank you all for allowing us to come speak to you today. Again, I'm Mike Higgins. This is Drew Noble. Drew's an intern at Braskem, so we both work for Braskem right now. Drew's trying to figure out what he wants to do with his life. He's maybe a couple years ahead of you guys. He's had some internships, and he's got an internship at our plant right now. So I want to talk to you. I got 3 pieces. Did anybody catch how many slides were up there? Did anybody see that? Were you guys paying attention to that part? Oh, you really should have been paying attention. Sorry about that. So, yeah, it depends on how fast I can get through these 65 slides. So you guys might be here a while. Okay, so I plan on doing kind of an industry overview. I'll talk about Braschem. I'll talk about stuff that he does as an engineer. And then I'll talk about career path and give you guys a chance to ask questions about career paths or what you want to do, anything like that. I have my own opinion about stuff, and it's my opinion. Somebody else will give you their opinion. So go Reds. Okay, so next thing, petrochemical industry. I've worked 20 years, 24 years in chemical plants. It's what I've done. I co-op doing that in college, and been doing it ever since. So we end up falling in, chemical plants are probably in one of these two generations right here. Somebody gets oil and gas out of the ground. They do some kind of first level separation. So in a chemical plant, I might do that. Or right now, we work in this kind of second level where we take propylene. We're right across the river from Catlettsburg Refinery. We take propylene that they could burn in a flare, and we make plastics out of it. And we make all kinds of plastics out of it. That's stuff you don't care about. So Braschem. Braschem has, I don't know, add up all these numbers. You guys are engineers. Add up all these 1s and 2s and 3s. Use your fingers and toes. That's how many plants we have. I work in the polypropylene business. So inside the U.S., we've got 5 polypropylene plants. I've been to each one of them. In Germany, we've got 2 polypropylene plants. I've been to one of the 2. In Brazil, we've got, what are we up to? 1, 2, 3, 4, 6. I've been to 5 of the 6 different sites in Brazil. So for a simple life of working in chemical plants, it doesn't sound very glamorous. I've got to travel around a little bit. But I didn't get to travel just because I work in the chemical plants, because you choose to do something, gain an expertise, or learn something more than just showing up to work every day. This is a little bit about the industry. So I said Braschem, you said who? And I said, well, Braschem's actually the largest polypropylene producer in the U.S. And you said, wow, I didn't know that. So what's polypropylene used for? You name it, it's used for. Braschem believes that the products that we make your lives better. It goes into cars to make cars lighter, which improves gas mileage, which reduces emissions in the environment. It's used in construction, industrial, any kind of consumer good, packaging. Your plastic that has a little bit, the majority of polypropylene that has a little bit of a haze to it. So lids on water bottles, right? That's all polypropylene. We make grades that are a little higher, different quality for different purposes. We can get them clear, and it depends if you want it. If you want them clear, we can get them that way, but it might cost you a little bit more, right? That's supply and demand, so you get a little bit about economics as an engineer also. Our particular plant, these are our components, right? So even though, 36% of the product that we make goes into personal and home care, whereas for the overall portfolio, it's only 10%. So we have a large piece of that product for Braschem. So that's what we look like. That's our manufacturing unit. If you drive down the road, you drive by a chemical plant and you see 2 big loops like that, think, hey, that's probably a polypropylene plant. Just checking. So you don't care about the site, the numbers, but at the end of the day, some numbers that you may care about. We pay about $9 million to our employees every year. We spend $2 to $3 million in contractors coming in and building and working on things for us. We purchase $4 million worth of goods from around the area and across the country. We spend $5 million just rebuilding the plant, fixing stuff that's broke that needs upgraded. Our plant's worth, at a minimum, $300 million. This is the refinery. This is us. When did we start? Give me a date.
October
1961. So my site was actually I mean, before I was born. My site was actually a polypropylene plant for the first time. This is the first technology, first big investment in this area. So New York Times, 1961. I found that pretty amazing. So this is the history of the plant you probably don't care about. I'm getting the stuff you care about. So what are we up to? We're probably through at least 20 of my 65. We're doing good. What do we got? I still got 15 minutes. We're cruising. So what do? We take, if you wanted to be an engineer and work in the plant, we take a raw material. We take propylene. What do you think we make from propylene? Blue shirt on the end. Either blue shirt on the end. Anybody with a blue shirt for bonus points and a gold star. Polypropylene. Great job. I got it, man. Oh, wait a minute. I got it. I'm going to write it right on your hand. So, again, why did I get to go to Germany and go to all the sites in the U.S. and travel across Brazil? Because I'm learning about this piece of it, and we're sharing, right? So Braskem's got, let's just say it's 10 different sites that make the same thing with the same technology. Do you think they want me and my plant to learn from somebody else at a different plant who already figured out how to do something? I'm going to go with yes. Okay, great. And do you think you're learning that in your engineering classes? I'm going to say you're not. I'm going to say not. I'm going to say that your professor isn't saying get up and go to the back of the class when you don't know how to do that problem on this test and get them to help you. But that's what we get told to do. We get told to collaborate. We get told to don't do the same stupid thing that somebody else already figured out how to do. Go ahead.
So are you learning how to refine material more when you go to
Oh, we're not refining. We're creating. Right? We're taking propylene and we're creating polypropylene. Ziegler Natta, the guy from 1961, right? He was the first guy. They discovered that technology in 1961. How do you take a bunch of propylene monomer and what's the Disney stuff? You drizzle some pixie dust on it, and you get it to all combine in just the right way and make the product that you want. If you do it too much, it gets too sticky, and if you do it too little, it doesn't set up as a plastic. And it's just we create. That's a great question. Thanks for the involvement, by the way. Okay. You don't care about how the site's laid out. You may or may not care. Yeah. What's that? Okay, for the young man who missed my point earlier. No. That's what we make. So what do we get to make polypropylene? We get propylene. Very good. It seems pretty easy. Sounds pretty easy. You just get some propylene, make polypropylene. You walk into Lowe's, you can buy some urethane or polyurethane. What's the difference? Just go get it off the shelf, put it on the wood floor. What's the big difference? Come on, there is some difference. Okay, again, you don't care about what the site looks like. These are rail cars. You may or may not care about rail cars. The guy who was in here, the professor who was in here earlier who talked about designing roads, there's somebody, the whole infrastructure around rail and rail systems, there's engineers for all that stuff too. Not near as exciting as chemical engineering, mind you, but there's stuff for it also. You don't care. You care about the pictures. The pictures look good. Does anybody see anything in this picture? Now I'm going to have to go back a few slides. This picture right here, right? Got it? It's in your mind? Let's go backward a few slides. Let's look at this one. What looks the same? Huh? The towers since 1961. Yes, we got color since 61. That's very good. So the towers are the same, but, oh, wait a minute. Let me go back. Back. History of the plant. The plant from 61 was made to make how much? Anybody know what double M's mean? Do you guys know how to write cursive? I was told they don't teach that in class anymore. You guys know how to write cursive? There'll be a gap. Crazy. Anyway, 37 million, it's million by the way, 37 million pounds that these splitters were designed to process. How big is the plant now? I'll fill it in blank for you. 500 million. That could be a test question. How big was the old plant when it was built in 61? 37. How big is it now? 500. What's the same? The towers. How do you make the difference? How do you get? What's the difference between that? What's the difference between 500 and 37? Efficiency. It's the guts. It's the stuff that's in the middle that we create. We take new technologies and we take the same old stuff and we can make a lot more out of it. And we learn from, actually, there's 2 sites in the U.S. that have splitters. We're one of the 2. A lot of people are learning from us on this one. Okay. All right, so that's enough that I want to talk about that. That leaves 9 minutes. We're not going to talk about flow diagrams because I don't have a lot of chemies. Drew, this is going to be your time to shine, young man. So I'm going to throw some stuff up here. So what's an engineer do? Drew walks in the door. Actually, some of these were his predecessors. Some of these weren't. Drew walks in the door, and we say, we're having trouble flowing water, chilled water to be exact, chilled water around this process loop. We're not getting the flow rate that we need. We're having trouble with this pump running. So did that just like, okay, well, I don't know anything about control valves. I don't know anything about pumps. I don't know anything about chilled water loops. What's the important thing that you just said there? So what's the takeaway on this slide? Other than the fact that blue and green are the same 2 colors as the Ashland bridges, blue and green, right? Right, that's the same. And on a percentage-wise, blue and green is about 10% of your shirt colors in here. Of course, I am an engineer. What's important about these 2 slides, or about this slide? No clue, Mike. I don't know. Yeah, so they're not flat. Like to an engineer, flat is good, bouncing around bad. That's what we got to fix. So I think I could go through, I had all kinds of good stuff I was going to share about this. High pressures, low pressures, flow rates, but not. So no test questions on flow rates and pressures. Okay? All right. Okay, next. So I'm going to get to one of Drew's projects. Here you go, Drew. You're up.
All right, so in our F&S building, so our finishing and shipping building.
The green dot is at the top. There you go.
Okay. So in our finishing shipping,
Thank you.
the
Who needs a microphone? This isn't a microphone. This is your test questions right here.
So after we make the polypropylene, install with additives based on what product we need. So, and here we see, this is our mixer. This is where we add our additives to mix our ingredients with our polypropylene. That's it. You get the products. Like some products require kind of xylene.
Skip it over their head.
Got it. Okay. So one thing I've designed is this mixer really kind of dangerous. So what I've designed to do is my predecessor's help is we're going to add this trolley beam that's going to lift this feeder. It's going to lift it up. So this is where it is.
Keep, click, it'll show it. Click on, click on, click on. One more. Oh, look at that. That is where it's at. Can you guys do that? Do they teach you that in school? How to make that animation? That is wicked. Is it? Yeah, okay.
But working with this project, there's a lot of steps. It's not easy. It's not just, put this here, lift this, and move. It's not that easy. Multiple steps.
Next slide. This is the lifting locations.
Oh, okay.
He hasn't, to his defense, he has not seen the slide deck. I threw him into this, okay? seeing how he does. This is part of his training as an engineer. You didn't learn this in school. You learned it on the job.
So, like a simple engineering thing, it's not really, we're chemical engineers, but this is more, I guess, mechanical. But it's physics, you know? We had where is this, center of mass? I'm not sure how far you guys are in physics, graduate classes, but, you know, if you look at things, if your one string or chain we're using is too long, then you want it to be even. Because if you don't, you're gonna end up with this, you're gonna hit stuff, but just little steps like that, you gotta be, every minute detail is important, you know, so that's throughout the process. Yeah, so what I've done so far is also one of the hard problems, I guess it might be overhead, but scheduling is hard to do. We've got to work with people around the plant, you know, it's not just an individual task. So like this lead sampling, you would think it's easy, just strip some lead paint. It's not. You know, our feeders are running all the time. And just dealing with schedulers and operations, and actually dealing with duties. It's a challenge.
Oh, it's not a good one.
Continue.
Yeah, go to the next slide though. Get to the pictures with animation.
Okay, so
One more click. Oh yeah, that's it. It's good stuff.
a little overview of this. We have a tank, let's say GAJ, and there's a level flow down tank, so we flow down the steam condensate. If your level gets too high, which as you can see here, this thing is broken. They'll get up. So right now we're manually controlling it. It's high and low. We're losing a lot of steam. And steam, you know, steam's energy, and energy costs money. So when it comes down to it, we're trying to save money. This is one of these projects where this design is supposed to save, I think,
Next slide. There you go.
$22,000 a year annual savings projected. So simple projects like this, probably gonna put, I'm not sure how the quote was, but like 3,000 to 4,000 into it, and how much we save. And these projects are going on around all over the plant. It's really helping companies with health benefits.
Okay, so Drew is going to say, Higgins, why didn't you tell me I was going to talk? I did. On the way over here, I said, Drew, I'm going to give you a chance to talk. But I didn't tell him like when and how and where and all that stuff. So to his defense, I thought he did a great job. Huh? Do you want to keep going? No, I don't think you know about this one. It's okay. Again, this is small stuff. Another project his predecessor worked on. Oh, that was bad. That's good though. This project was all about, it saved $10,000 in condensate, right? So I bring Drew in. If Drew works on one project that saves $20,000, am I really that boring? I mean, I was really trying to keep it lively. Anyway, if he works on one project that saves $20,000, he paid for himself. I can go to my site leader. Again, this is just economics. Why do you want to hire an intern? Well, if he does one thing that saves $20,000, he paid for himself. So if he does two things, now we got money in our pockets. If he does three, that's like real cash at that point. So, and every one of these things, all this stuff, and 95% of this stuff I will guarantee, Drew isn't learning in class. You aren't learning in class. You're not. The biggest thing that you can take away from any of this is when you don't understand something, start taking it apart. Ask questions, take it apart, figure it out. If you want to be an engineer, that will help you. If you have any kind of desire to do any kind of engineering, when something is a problem in front of you, if you're turning around and going the other way, it may not be a fit. Just telling you, just may not. Because engineers see problems, they try to figure out what's going on, they come up with solutions. Outside of school, then you're taught to collaborate. Of course, you could probably collaborate inside of school also, doing your homework, but just not during tests. That's still a no-no. You might even sign something. Anyway, so the collaboration piece is big. This one was awesome. This one was, what is that? Anybody know what that thing is? So we'll walk around the plant like I could say, hey, what is this? And most people, I don't know. I don't know what is that. I don't know what that is. That's a control valve. That's a gate valve. What's this big blue thing? Yeah! Test question 3. The big blue thing is a pipe. Okay. This one, again, chemical engineer. He goes in, EPA has some regulation. If I got a tank, it has to have a dike around it, and that dike has to be so big. Well, something changed from when time this tank, let's go backwards. Something changed from the time that this tank was put here and this dike was built, but at the end of the day, we need more dike capacity. And we also needed to modify like our piping around it. That's pretty cool stuff right here, which looking at it, you're like, it's just a pipe, right? No, that's a pipe inside of a pipe. Why do you do that? Why do you put a pipe inside of a pipe? Bueller. Okay, did that go over your head? Bueller? Does that ring a bell with anybody in here? Yes, all right. Thanks, man. Okay. So inside pipe leaks. I don't want it going on the ground. Outside pipe catches it. It's sloped. It's sloped to go all the way back and go back to that tank and drip inside the containment. That way, if it drips, it doesn't drip outside. And on the other side of that fence right there, anybody know what that is on the other side of that fence other than the property line? What's on the other side of the fence? The river. Good job. Diesel fuel in the river is bad. So, right, something changed in the regular. So a chemical engineer had this project to get some more capacity. So he had to work with an engineering company on cement and how to modify this structure and rebar and coatings, and then he designed the piping to go along with it. So my point is this: if you're an engineer, yeah, you got a discipline, but you should be able to like attack a lot of stuff, because that's just should be how you're wired, should be what makes you click. Great before and after pictures. So this is one of the last things, and then I'm going to give you time to ask questions to Drew. Why? It's overrated. This is like literally, it's like the last slide. I mean, it's the last slide. So what we do? We kind of talked about industry. We talked about Braschem. We talked about stuff you could do as an engineer, and this is like career path. So again, I've worked about 24 years. I've worked in chemical plants. That's all I've done is worked inside chemical plants. I've worked in different areas. I've done production engineering, which may not mean anything. I've done process engineering, sound pretty close. I've managed capital projects. I've been a superintendent. Process engineering is way more complex than you know what? I got a great saying. I like it because I said it. But, if I said, what's your name? Kane. Caden. If I told Caden, go, I don't know, change oil in your car and pump up the tires and, I don't know, wash and wax it. It sounds pretty easy, right? It always sounds easy unless you're the guy doing the work. That's the bottom line, right? If you're the guy doing the work, I just gave Caden, what, 5-6 hours worth of work? Pretty easy for me. If you're the guy doing the work, it's a lot harder. So any of this stuff on the surface, the purpose of that point is all on the surface, all this stuff seems pretty easy, pretty simple, not too complicated. But there's so many levels below it, so much depth to it. So, and in the course of my career, this was more like in the first half of my career, I do have 3 patents on different pieces of chemical plants, making modifications to them. Why? Because something didn't work. We needed to come up with a solution. We figured something out and got some patents out of it. I think it's pretty cool. But, So, but career path. How many have worked for 4 companies? It's my last bit of wisdom. Write this down. Test question. I might have worked 10 years for BP and got really good, and I moved up, and I was a superintendent and did different stuff. But when I changed jobs, let's say company A, company B, when you you might do different things inside of an organization, but if I really wanted to live in Huntington, West Virginia, the only job that might be available is not doing what I did. It might be a different job. It might be one of these other jobs that I learned coming up in the previous 10 years. So the test question is, in my opinion, what's really important? What's really important is staying technical, okay? Stay technical. Don't forget how to do stuff. Don't forget how to do the technical work, because at the end of the day, it's something to fall back on. There's always going to be a need for people who know how to do stuff. There's a less of a need for people who can say, yeah, Caden, I need you to go wash the car and pump up the tires, right? So there's less of a need for people who give the orders than there is a need for people who know how to execute and get stuff done. So stay technical. That's my wisdom for 24 years to you. Okay, I know I'm not near as exciting as Drew, so anybody got any questions? Drew's third, fourth year, senior. Drew's a senior. Got one more year and he'll graduate. He's had a couple different internships. Anybody got any questions? There better be something. Anybody in a gray shirt, you get first chance because the blues and the greens took over earlier, I know. So gray shirt, yes.
What internship was most impactful for your
You don't have to say Braskem.
Well, actually, this is my first industrial internship, but I did research before. And, you know, it's a good thing that the 5 week like and 5 week don't. Me personally, I did research for a whole summer. Wasn't a huge fan. But it's good I went through it and I know I like industry and I like the job right now. It's early. We'll see, but, you know, I think as an undergrad, because I was still in school, it's important to be your horizons out, you know, test what you want, test different fields, get as much experience as you can, because after you graduate, you're going to need a job, and that might be a job for a while. So, the experience is not the best.
So we've got get experience and stay technical. 2 good test questions right there. Yes, white shirt. Whites are now floors open to whites. White shirts, white shirts. Come on. Come on. Go ahead.
Does Braskem do any research into your development of what happens to their products after you guys ship it away from the plant or refinery? So after your products are done and they've already been used for whatever you originally intended them to be used for, do
Yeah.
you guys do any research into what happens afterwards as far as their disposal and maybe what you guys could repurpose them for?
Yes.
Or is that kind of out of your guys'
Well, I mean, part of that depends on you all. What's important to you all? You know, I drink my water bottle. If it's important to me that that doesn't end up in a landfill, that's how you speak to industry, right? As far as recycling. So does Braskem care about the products that we make? And you know, there's only so much stuff in the ground to satisfy all the consumer needs that we want. And I'll live long enough that it won't affect me. You guys, definitely your kids. Your kids, if you guys don't, if recycling isn't bigger and you know, how do you reduce the use of all the natural resources? The only thing you can do is recycle it. So do we care? Yeah, Braskem cares about sustainability. At the end of the day, so if we need to change for our business to stay sustainable, then we'll do that. And we've got a whole leg of the company that's on sustainability. So think of your business. Part of it's paying the bills today, right? We're running the plants. I got I&T people doing research trying to figure out what's the next thing happening. And then I got people thinking past them about, okay, this company, if we want it to be around, what do we need to do to keep it around? So yes, to answer your question, is it in my world right now? It's not in my world, but it is part of the company's world. So I saw movement in the back. Movement? No, okay. Just checking. Yeah.
Any questions? Any more questions from either of our speakers? All right.
Thank you all.
All right. First off, let's give them a round of applause. before you all leave, there's something I want to say, a piece of advice I have. You're going to spend the next 4 years talking about differential equations and mechanics and chemistry and all this, but one thing that they both hit on that's incredibly important are the soft skills, the communication and management. When you all get to senior design, we're going to put you in teams and we're going to give you an open-ended project and we're going to say go. And it's going to be your first time in a real scenario where we don't tell you what to do. The faculty doesn't tell you what to do. It's you telling yourselves what to do. And I've been doing that process for a while now, and all the feedback I get from the students is the equations and stuff. That's easy. It's actually working with my team and getting stuff done on time. That's a challenge. Setting your own goals, setting your own deadlines, and so that stuff's important. And so it's something to think about. That's all I have for you this week. Couple things. Sign-in sheets in the back. Don't forget to sign in. Pay attention to your quiz. It'll be due next week. Y'all have a great weekend.